Hi everyone, this is Moinak from Sikharthy Infotech. Today I am going to show you a small tutorial on how to visualize data using Python. So I am going to use VS Code for this tutorial. First of all, let me create a folder in my desktop. I am giving the name of this folder as data science. Okay, so I am opening this folder in my VS Code. In VS Code, I need a few sets of tools for this purpose. Like from the extension marketplace in VS Code, I need to install few tools which I've already installed in my system. Those tools are the Jupyter Notebook and the Jupyter Lab and the Python interpreter tool. So let me create a file in my Explorer. I'm giving the name of this file as program.ipynb. So normally Python script files are of .py, but .ipynb files are the notebook file or the Jupyter files using which we can visualize our data. So we can see that there is an option called select interpreter. Okay, in my system it is currently detecting the Python kernel. In my system I have two Python kernel. One is the Anaconda global environment and another one is the base kernel, which is my Python system interpreter. So the system interpreter is of version 3.11.1 and my global version is 3.12. So I am selecting the kernel of Conda because using the Conda base or the Anaconda environment, all the tools we require for the data science purpose or the data visualization purpose are pre-installed. Okay, so the prerequisites are satisfied for this tutorial. So in this program.ipynb file in Python, there are few libraries like there is a library called matplotlib, there is a library called numpy, there is a module called random. So using, and there is also a library called pandas. So using these tools and libraries, we can generate a graph or we can visualize the data. Okay, so let me first of all select the kernels over here. Okay, you can see now my kernel or the base Python 3.11.5, which is of the Anaconda environment, is ready. So first of all, let me import all the packages. So first, I am importing NumPy first. Next, I am importing Matplotlib. From the Matplotlib library, there is a module called PyPlot. So I will import this PyPlot module and I will import as an object PLT in my program. Next, I am importing the module called random. So import random. Okay, so I have used these libraries, the matplotlib and numpy are the libraries. Okay, from the matplotlib library I have used a module called pyplot to plot or visualize the data over a graph, and I have also used a random module. So random module is basically used to generate random integers or random strings or random characters, anything. But for this purpose or for this tutorial I will use only the random integers, that is the randint. So next I am going to create a class. So I am giving the name of the class as class plot. Inside this class I am going to define a function using the def keyword in Python. So what is def? Def is basically nothing but the full form of define. So I am defining a function called main. Inside this main function I am going to create two coordinates. Basically one coordinate will be for the x-axis and another one will be for the y-axis. Now normally in graph, basically in a 2D graph, we can see there are two axes, and in 3D graph there are three axes, x, y and z. This tutorial I am just going to show you how to generate a 2D graph over x and y axis. Okay, so inside my main function I am going to define a variable called x underscore axis. Okay, so in x underscore axis I am going to take some random integers. So my numpy module is np, which I have initialized as np dot random dot randint. So we are going to generate random integers using the random module starting from 10 to 90, and it will give us 10 outputs. So basically inside the function randint, you can see there are three arguments or three parameters you can see. First of all is the 10, which is the starting value, up to 90, which is the last iteration value, and the value it will, and the total number of values it will generate inside the x underscore axis coordinates is 10. That's why we have given at the end 10 comma 10. Now for the y axis, y underscore axis equal to same np dot random dot randint. I am going to generate the same values over here, so starting from 10 up to 90, and I will generate 10 values. Okay, so over here I can see that my x and y axis are declared or defined. Okay, so next what I am going to do is I am going to print the coordinates. Okay, to print these axes, so print x underscore axis to check that my values are getting stored under this variable or not. So y underscore axis, since I have done this program inside a class and inside a function called main, so I need to call this class and function. So plot dot function main. Now I am running this code, or I'm not, this is, since this is not a Python script file, it is a Jupyter notebook file, so I am running this cell. You can see that it is showing me that it is connecting to the kernel 3.11.5, which is my Anaconda environment. Okay, as I told you previously that I am using Anaconda environment since because all the libraries and all the packages are already there inside the Anaconda. I don't need to install all the libraries and packages separately. Okay, you can see it is just importing the packages numpy. Let's wait for a few seconds to get the code compiled. Okay, till my code gets compiled, I am just adding few lines of code over here. Okay, so those are, I am just plotting these two axes using plt.plot. Plt is basically my matplotlib object. Okay, with the matplotlib.pyplot object I have initialized as plt, so that's plt.plot. Inside plt.plot I am adding my x underscore axis coordinates and another one for y axis, plt.plot within bracket y underscore axis, the two variables I have defined. You can see in the below cell there is my output. Okay, so what is my output? You can see there is an array of x-axis. To be more precise and more descriptive, I am just adding a string over here to make everyone understand that these are the coordinates of my x-axis. And similarly for the print of y-axis I am adding the coordinates, and I am giving a string over here that these are the coordinates of y-axis. Okay, I am running this code or this cell again. You can see that the x-axis and the y-axis coordinates are plotted accordingly. Okay, and below this plotting there is a graph, there is also a graph which is coming in the output, that is the x and the y-axis plots. These are the x and the y-axis plots. Okay, so according to this program what happened is that in x-axis we have taken, or we have taken as input as few random integers starting from 10 to 90, and we have generated 10 values. Similarly for the y-axis also we have generated few random integers starting from 10 to 90, and there are 10 values. So what we have done next is that we have plotted this x and y axis. Okay, and after plotting this x and y axis we can see there are two lines which are actually showing. Okay, to identify these two lines, which is actually which line is for x axis and which line is for y axis, what I will do, I will set color for these two lines. First one I am giving the color as blue for the x axis, and the second one I am giving the color as red. So I am running this cell again. So see, by visualizing we can see, or we can find the we can show, we can get the difference that which one is actually the x-axis and which one is actually the y-axis. You can see that I have set the color of x-axis as blue and the y-axis as red. Now this is my graph which is generating. Now this graph in this coordinate section where it is showing over here x and y axis output, each and every time I am running this code, you can see we are getting different values in under x and y axis, because it is of random integers, and each and every time we will run this cell we will get different values. Okay, so what we will do, we will now add the marker interface to this graph. So what a marker interface? Marker interface is basically nothing to actually show at which point the plots are there. So there is an attribute called marker attribute. Inside this marker attribute, I am giving the shape as O. Okay, the alphabet O. So for the y-axis also I am giving the marker as O, and I am running this random integer graph again. You can now see that the graph which is now generating, it is showing the plots or the points where the plots are there. Okay, but since this is not an versus graph of x and y axis, it is just showing the individual line of x and y. Okay, we can also plot a versus graph over here. How we will plot a versus graph? Under this we will go to plt.plot. Inside this we will mention two axes at the same time, so x-axis also, and in this plot function y-axis also. And I will set the color of this line as, suppose say, orange, and I will give the marker as O, marker interface as O. Now I will run this code again. Now you can see that there is a combination of x and y axis graph, and there is a combination. Now this one, the orange line which showed in the graph, this is basically the versus graph. What is versus graph? Versus graph is nothing but the x axis plotted with respective to y axis. Okay, so this is the versus graph, and these are the individual graph. Okay, the blue line is representing the x axis, and the and the red line is representing the y axis. So this is basically line. We have plotted this graph as a line plot. Line plot means it is a simple representation, or the points which are connected by a line only. The points or the plots which are connected by a line only represents a line plot. So next we are adding a new cell over here, which I am going to show is now that the pie plot. So what is actually pie plot? Pie plot is basically nothing. It is a pie graph. So in pie graph, what happens that we cannot plot two axes or a versus axis at the same time. We need to use only a single axis. So let me define all these random matplotlib and numpy libraries, all these import things first. And I am calling, or I am defining a class test. Inside this class test, I am calling or defining a function main. We can also call this previous function from this last cell, okay, to access all these features like this x-axis definition or the y-axis definition. But in this tutorial I am just defining these things in this new function. See, I have used this function main in this cell, but in this previous cell I have also used this function main. But since these are two different cells in this Jupyter notebook file, there is no connection with this main file with that, this main function with that main function in the different cell. Okay, so inside this main function I am going to define x-axis only using np dot random dot rand integers, and I will generate 10 to 90. I will start, my starting value is 10 and it will go up to 90, and I will generate 10. I will generate 10 values, and I will store these values inside a variable called x. Now why I am storing this variable inside this value called x? This is because I want to visualize this data. Though those who are having the prerequisite knowledge on Python, I think they know that the array value can be stored at anywhere. Okay, so if I want to check the dimension, it is also possible to check the dimension using this ndim keyword. What is ndim? Ndim is n dimension. Okay, And to check what is the type of this array, since we have used numpy, we can also use x over here, means the variable which the array is in. So test dot function name is main. Now I'm running this cell. You can see the dimension of the array returned as 1. That means it is a 1D array. And the type which is actually it is showing for the numpy array is numpy.nd array. So what is ND array? ND array is basically nothing. It is n dimension array. Now in Python, in core Python, there are actually four type of arrays. The four data type of arrays. Those are list, set, tuple, and dictionary. But in advanced Python or in data science Python or machine learning Python, there is the array we normally use are NumPy arrays. NumPy arrays, why we use them? Because those are dynamic arrays and where we can create multi-dimensional arrays also, which is not possible in list, set, tuple, and dictionary. Okay, now see, I am just commenting out these two lines, and I am defining plt.py over here. And inside this py function, I am just calling my x-axis. And plt.plot function actually shows our graph. So I'm running this. So see, this is my pie graph which is generated over here. But to make this pie graph more visual appealing, what we will do, we will give over here x-axis comma shadow equal to true. It is a boolean value. I am setting the value of shadow as true. Why? Because it will show a shadow just below the pie graph. See, there is a line of shadow which is coming below the pie graph. Okay, now in another variable I am decreasing the value to 6, so it will generate 6 values and will store inside my pie graph. Now to identify which one is which value, what I will do, I will define an array of labels over here, labels equal to, now this will be my list array, these are list data type of array. So I am giving the first name of the first element as A, second element as B, third element as C, fourth element as D, fifth element as E, and sixth element as F. So what I will do now, I will just put over here, I will give this labels function over here, and I will call the labels list or the array. When I will run this, it will actually show which one is which plot or which one is which portion in the pie chart. Okay, now there is another thing called legend. So plt.legend, it will actually show that which color represent which plot or which section in the pie chart. Okay. Okay, now what I will do, I want to differentiate this, for example, this E thing, E, the section E in this pie chart separately. Okay, so section E is basically my fifth value. So I will create another array over here as explode. In this explode function, what I will do, I will set all the values to 0 until the fifth value. Now the fifth value I am setting as 0.3. So see, 0, these are first 0, second, third, fourth, fifth, and last one is only 0, because I want to differentiate the fifth value from the remaining values, that is the portion of E in the pie chart. So I will call this explode array over here, explode. Now I'll run this. Now see, this E portion is separated from the other portions in the pie chart, okay, or from the other values in this pie chart. Okay, the E represents by the color purple. Okay, I can also set my customized color over here. Means if I want to set the color of A to suppose red and the color of B to blue, color of C to yellow, I can do this thing. Okay, by defining another array of colors. Okay, and then calling the colors inside those, like using the keyword color and using this color array. So in this, now I'm coming to this first graph. I forgot to mention one thing. We can also add over here this line plt dot grid to visualize more advanced or more graphical way regarding the plot. The graphical way, what I mean to say is that the graphical way means we can visualize that at which grid or which point the exact plot is happening in this graph. So I'm running it again. You will see that there is a grid which is coming behind the line plot. See, these are the grids which are coming in check boxes. Okay, I can also change the color of this grid, so I'm changing the color to green. Okay, so these are the grids. So grid are usually basically used to visualize that this plot, for example, say this plot, okay, this plot as is at which, or at which falls under which x-axis and falls under what y-axis value. This grid actually helps to visualize those things in more advanced way. This is the utility of grid, using grid. That's it, guys. So I hope you guys like this session. I will explain more about this dynamic arrays and more about this data plotting thing in my next tutorial. Thank you.